Welcome and hello. This is a video tutorial on HEC ResSim, and in this lesson, I'm going to be talking about observed data. Observed data is data that is observed about the reservoir system and compared with the actual ResSim results to improve the model. The user is able to input observed data into reservoirs, junctions, reaches, diversions, and diverted outlets. Then in the alternative editor, they will see a list of these locations for the observed data in a table in the Observed Data tab, along with the DSS path and information associated with it. So I have a reservoir network here on this screen. I'm in the simulation module because I've already ran a simulation, and I'm going to show you two examples of observed data in this lesson. All right, so if we go ahead and say right click on the reach, edit reach properties, we've seen these tabs for routing and losses. Now we also have this tab for observed data. And this has been here all along. It exists in the reservoir network module as well. And like I mentioned, it's true for reservoirs, junctions, diversions, and diverted outlets as well. If I wanted to actually add observed data, I'd click this checkbox right here. Now, for my two examples in this lesson, I'm going to use one for the reservoir and one for the junction. So let's go ahead and make edits. I'm actually, since I already ran this alternative, I'm going to do so from that alternative. So I'll select reservoir here. This is the same thing as the reservoir editor if I had right click, edit reservoir properties. Same look and feel, where we have the physical tab, the operations tab, and this observed data tab. So if I toggle this off and click apply, and then OK, and if I go over to my alternative editor, the observed data will have no records here. Let's go back to, again, the reservoir, observed data. And if I click this checkbox for the pool elevation and then click apply, OK, and then go back to the alternative editor and observed tab, here I have a record for the reservoir one pool, and then the variable is the elevation. Now I already have a data set assigned because I was prepping for this lesson earlier, but I'll go assume it's not assigned. I'll go ahead and take you through the steps. Keep in mind, this is the observed data. So this is an external data source, not associated with the simulation. So it was not computed. It's used for comparison purposes. All right, so I'll go ahead and click this select DSS path. Then what I want to do is navigate to the DSS file by clicking open. This is the DSS file where I have that observed data saved. So it's here. I got it saved over in just the main simulation file. It is right here. We go. It is right here. We have reservoir pool elevation, and then here's the original that was generated, and then this is the observed data. So I could go ahead and set path name, and then close that. And when I click the set path name button, the data filled in here. So I can go ahead and click save and then close that. All right, I could run the simulation again. It wouldn't change anything. It would still regenerate the same pool elevation during the course of the simulation. What I want to do though is open up DSS view. Here's DSS view, and I want to compare the model results with the observed data for that pool elevation. So I'm going to click on reservoir pool as a filter. And here's the elevation from the model. And then here is the time series data set elevation that is observed. So the only difference is I appended the word observed to part F in the file name. I'm going to go ahead and click the plot button here. So if I click green, this is the actual model elevation in the reservoir pool. And then the red is the observed. So we see over the course of the month that the observed data is lower and lower compared to the model output. Now, if I wanted to actually use some math functions to do that calculation, we could do that in DSS view. I have these two records already selected, so that's good. I could go up to tools, math functions. I know this is a little bit beyond the scope of observed data sets, but whatever. So the data set I have selected is the model version. And what I want to do is subtract the observed data, and I should get a positive number because observed data was a little bit lower. And I'll go ahead and click compute complete. So now what I want to do is save that data set, but instead of observed, I will just say difference. ResSim minus observed for my part F and click OK. And then a new record has been created. So let me go ahead and close that and then view, refresh catalog. And again, let me filter to the reservoir pool. And here's the new record right here. So let me just go ahead and plot that. And sure enough, we see that the difference slowly increases over the course of the simulation period, which I chose to be June 2024. So from this information, we know that the difference of the water surface elevation in the model in the reservoir pool versus the observed data increases linearly over the course of the month. And with that information, we can intelligently tweak our model to more accurately represent that observed data. What does that mean? Maybe we could adjust the evaporation, the leakage, or the seepage. Perhaps our inflow is incorrect. Perhaps the pool geometry needs to be adjusted. That really takes a lot more thinking and investigation than I have time to do. And now I want to do an example for junctions. So I'm going to close this. I'll minimize DSS view and then head down to CP4. So I'm going to click on junctions. Again, for junctions, we have the tabs that we've seen before: info, local flow, rating curve, and observed data. Let me just first point out, I do have a rating curve assigned. It goes from 0 to 30 feet, and then that's 0 CFS up to 22,000 CFS. So that's important. And then also for observed data, we need to go ahead and check a checkbox here. So let's check it by the stage and then click apply and OK. In the alternative editor, we now have a new record for CP4. So what I'm going to do here is select CP4, then click select DSS path, and then find that record. And it's going to be in here. And I have it saved for CP4. And then here is the record as well. So I'll click set path. And then doing that, assigned the record here. So we'll go ahead and hit save and then close. I could rerun the simulation, but that's not necessary because I've already ran it. So let's go over to DSS view again. And instead of filtering for reservoir pool, we'll filter by CP4. Here it is. And then here are the two records for the stage from the model. And then below that, the stage that's observed. So I'll click the plot button just to get a quick view. And now I have two nearly identical stages. So this is the model, and then this is observed. The only difference I notice is at the highest stage, we have some differences. So let me zoom in there. This right here in magenta is the model, and then the observed stage is this darker color, gray. So what this tells me is maybe from 27 foot on that rating curve up to 30 foot, we need to modify the maximum flow of 30 foot. And since the observed data was higher, that means the flow is actually going to be lower in the rating curve. So right now, the model data needs to be increased. Right now, it's sitting at 27.60. Let's just focus on this first bump here. So 27.6, we want it to increase to about 27.9. So I'm going to close that. Let's minimize HEC DSS view and then go to our junctions and then rating curve. And then I'm going to change this to something smaller than 22,000. Let's make it 14,000. See what happens there. Apply. Okay. Let's just recompute. Okay. Now let's go back over to DSS view. What I'm going to do is view and then refresh the catalog. And then let's filter by CP4 again. And then compare our two stages there, the model versus the observed. The model, this first record, that's been updated. The observed, that wasn't touched by ResSim. Instead of 27.6, we now have a higher value, which is 27.69. So it still doesn't match, but you can tell how we can look at the observed data and compare it to the model results in ResSim and then modify ResSim accordingly to hopefully get a more accurate and realistic representation of the real world in our ResSim model.